So we are going to go through your Chapter 2 algebra test. Make sure you correct all the mistakes that you made. Remember, always available inside the period for help. If you need to skip around to the problems that you need. Here we go. Questions 1 and 2. The directions are really long. It says complete the table and plot the solution points and draw a line exactly through the points. And I remember I had you cross out the last part of the directions that said find a different solution point on the line. We weren't doing that. I just want you to make a table and graph. You'll notice I added in another spot for some x and y values because I wanted more than 2 to give my lines a nice look to them. So starting with question 1, we have the equation y equals 1/2 x. Remember, when we have our slope is a fraction, we're choosing x values that are multiples of that fraction. So I'm going to start with just some nice numbers like -2. We always choose 0. And I'm going to go +2. This gives me some nice numbers to be working with. I'm going to do my work off to the side. Plugging in -2 for my first one, I have y equals 1/2 x times -2. When multiplying fractions, we make everything a fraction. Here you can either cross multiply or cross reduce. So I like to cross reduce or cross simplify. That's when I'm looking to see if I can divide something out, and I can. The 2's can cancel each other out, which leaves me just -1 as my y value. When I plug in my x value of 0, I have 1/2 x, or 1/2 times 0. Anything times 0 is 0. The last one, y equals 1/2 times 2/1. Again, you can either multiply tops, multiply bottoms, or cross simplify. Again, I can cancel 2's. Cross simplifying is my favorite, so I'm going to go with that. Now I have a y value of 1. And then we're just going to plot and draw a line. So -2 is about right here, down -1. Stop, draw a point. 0, 0 is the intersection of our x and y axis. That's the origin. 2, 1 means I run right 2, fly up 1. We stop, and we draw a point. Here, let me do this in blue. Do your best. You should be doing your best with your rulers to connect your points. Not too bad for me. There you go. Second problem, same idea. You're actually graphing on the same x and y axis. That's why I'm choosing to do different colors. So the first one is actually in blue, and I'll do the second one in purple. Okay, so we have the equation y equals x plus 3. Again, I'm just going to choose nice, easy x values. There is no, you will choose different x values than your neighbor. We just want nice numbers to plug in. But we always want a negative number in there, always want 0, and a positive. So, same idea, I'm going to do a little squiggle wiggle line here and plug in my values to get the y. So, first one I have y equals, instead of x, I plug in -1 plus 3. -1 plus 3 is a +2. Second one, y equals 0 plus 3. Well, anything plus your 0 is just that number, so I have +3. Last one, y equals +1 plus 3 equals 1 plus 3 is 4. Again, same idea, we're just going to plot these points. So at -1, I'm at +2. So I'm at run left, run 1, run up, or fly up 2. Stop, draw a point. 0, 3 means I don't run anywhere, I just fly up to 3, stop and draw a point. 1, 4 means I run right 1, fly up 4. Again, do your best with your rulers to be connecting your points. And there you go. This is question 1 in blue, question 2 in purple. Questions 3 and 4 both say solve for y. Okay, well this is not too bad. I'm going to put a little box around my y because that's the variable it wants me to find for both the problems. So I know I will be done when that red box is by itself. So let's draw a little squiggle line here. Separate my work. Question 3. Trying to get my y by itself means I'm treating everything like it's a constant or a number. That means x. I'm just going to imagine that's a number, and I would move it out of the way like I would any other number. In front of x, or to the left of x, there's a secret plus sign that tells me this is positive. There's no negative sign there. So to move my x, I have to undo what's positive, or do the opposite, which is doing negative or subtraction. I'm going to subtract x from both sides. This leaves 4y, again I'm going to put it in a red box here, equals, well, negative 12 and negative x, they are not like terms. They don't belong in the same family. I cannot combine these. I can't say this is negative 13x. I cannot say that this is negative 13, period. Nothing. They are two separate families. So we just write them right next to each other. So I'm just going to say negative 12 minus x. Okay, here's the tricky part. Now, to get our y by itself, we have to undo the secret operation of multiplication, so I'm going to draw that in so I don't forget. To get y by itself, I have to get rid of what's attached, which is 4. So I'm going to divide everything by 4. So it kind of looks like I just did 3 division problems. So now it leaves y by itself, exactly what I want, equals, simplify what you can. So negative 12 divided by 4. Those are like terms. I can do things with those. Negative divided by a positive is a negative. 12 divided by 4 is 3. Over here, negative x divided by 4. I can't do anything there. There's a secret 1 that's in front of this x, but the fraction 1/4 or negative 1/4 can't be simplified more than that. And I'm going to leave it as a fraction. You can write it as a decimal, but I'm going to leave it as a fraction. And I'm just going to rewrite it as negative 1/4 times x. So this is a nice answer, or you could also have y equals negative 3 minus x over 4. Both are acceptable answers as long as your y is by itself and everything is simplified. Question 4. Same idea. Getting y by itself means I'm treating everything else like a constant or a number. It means I move it like I would anything else. So that means 2x I treat as a constant, just a number. And right now there's a secret plus sign that tells me it's positive to the left. So I have to undo that by subtracting 2x on both sides. Now be careful, this is where people lost points. That when we simplify the left-hand side, we have a negative 3y. This negative has to be carried down. You cannot lose that. You lost that, you just messed up your problem. It goes together. It is a package deal. On the right, this does not simplify to 1x. 3 and negative 2x are not like terms. 3 does not have a variable next to it. They don't belong in the same family. Just write them next to each other. So I have 3 minus 2x. Do not combine them. If you combine them, you're wrong. And that means you probably lost points on your test here. Keep going, question 4. Still trying to get that y by itself. Secret operation of multiplication. To undo this, it's division. But remember, you're dividing everything attached to y. That means you're dividing negative 3, not positive 3, which I did see people do. Be very careful. That negative really does change your answer. Again, it looks like question 3 where I'm making 3 division problems. I'm dividing it by everything. So this still leaves y by itself, which is what I want. First of all, positive divided by negative is a negative. 3 divided by 3 is 1. It's not subtraction. It's not 0. It's division. Over here, if you don't remember to simplify, you're losing half a point. Here we have negative 2x over divided by negative 3. Well, 2 negatives make a positive, so I'm going to change that right away. And I have 2 thirds, or 2 divided by 3. I cannot simplify it more than it is. You could write this as a decimal, it's 0.6 repeating, but I'd prefer just to leave it as a fraction. So I'm just going to rewrite this as 2x over 3. Or you could rewrite your equation to be y equals negative 1 plus 2/3 times x. You can just rewrite it. It means the same thing. But if you lose that negative on that 3 over here, then you just made a huge mistake on your test. Changes your answer. Actually gives you a whole other equation. Okay, moving on to questions 5 and 6. Again, directions are the same. A little squiggle line. Now, because you have graphs, many of you like to use the triangle method, which is fine. Others use the slope, which is, again, also fine. I'll show you both. So our slope formula, m equals y2 minus y1 over x2 minus x1. Remember, it doesn't matter which point you decide to be your first one and which one's your second. You just have to be consistent. Question 5. Here we go. So I have a horizontal line. Well, there's no work if you're going to be really drawing a triangle. I can't rise anywhere. I'm rising. No, I'm not rising at all. So 0 represents my rise. And I'm just running. Well, I'm just going to run left to right. 1, 2, 3, 4. So my slope, if you're using a triangle method, which I can't actually draw a triangle, I'm not rising anywhere. My slope is 0 over 4, which 0 over 4 equals 0. 0's on top. You have an answer. 0's on bottom. That's a no-go. So our slope of a horizontal line is always going to be 0. So I'm going to say m equals 0. But I'll show you the formula too. I'm just going to let the reading left to right. I'm going to let negative 2, 1 be my first point, x1, y1. 2, 1 be x2, y2. If I plug this into my formula, this gives me 1 minus 1 over 2, careful, minus negative 2. This is why I like the glasses method, because I wouldn't lose track of this negative here. I would keep it with that 2. It does not get combined in. Two different things here. When I simplify this, that gives 1 minus 1 is 0 over 2 minus negative 2. Well, these two little negatives turn to an addition sign, so it's really 2 plus 2, which is also 4. Hey, look, I got to the same exact spot as I did my triangle method. 0 divided by 4 is also 0. Slope is 0. There really wasn't much work to do, though. You didn't have to do this. At this point in time, you should be able to recognize the slope of a horizontal line is 0. Okay, question 6, same idea. I'll show you the triangle method and the formula. If you use the triangle method, we first are going to look at the line. So when I look at it left to right as I'm reading a book, my line's going up, which means it's positive. So when I draw my triangle, I like to rise and then run if it's positive. You start at the lowest point, that's negative 3, negative 2, and you draw a triangle to rise and run to the other point. You could have chosen a different point. You could have chosen this negative 1, negative 1. You could have chosen 1, 0, but I'm just going to work with what they gave me. Triangle method means you just count boxes. So 1, 2, 3, I rose 3 boxes over 1, 2, 3, 4, 5, 6 boxes. So doing the triangle method, m equals rise 3 over run 6. Well, remember, you have to simplify every fraction. Even if it's a slope, simplify it. 3 over 6 is the same thing as 1/2. So this should be the slope I get when I use the formula. Again, it doesn't matter which one you choose as your x1, y1. I'm going to let also the bottom one be x1, y1, the top point be x2, y2. Plugging it in, I'll rewrite the formula y2 minus y1 over x2 minus x1 equals our slope. Plugging in our numbers, let's see, y2 is a positive 1 minus y1 is negative 2. That's why, again, like the glasses method, it keeps everything organized. Well, not glasses trick. Your glasses, subtraction signs, the bridge of that goes on your nose. X2 is 3 minus x1. Oh, another negative. It is 3 minus negative 3. Again, I'm going to put that in my little glasses so I don't lose anything. Simplifying this, let's see. We have negative 1 minus negative 2. Well, these two turn to a little plus sign. So it's really, what's 1 plus 2 over, on the bottom, 3 minus negative 3. Well, again, these turn to a little plus sign. 3 plus 3 is really the problem I'm working on. And we're just going to keep simplifying. 1 plus 2 is 3. 3 plus 3 is 6. Hey, look, I'm getting to the same spot. But I have to simplify this. If you don't simplify, you just lost half a point. So 3 divided by 6, that's the same thing as just 1/2. So final answer, m, or the slope, equals 1/2. Oops, wrong button. Okay, question 7. It says, which is steeper? A slide that rises 3 feet for every 2 feet of run. Those are some key words there for slope. Rise and run. Or a sliding pole that rises 5 feet for every 3 feet of run. And explain. So, first of all, I'm saying key words here for slope. Slope is another way to talk about rise and run. So let's just make our slopes. So we have a slide. I'm going to do my work over here. Slide, and then we have a pole. That's what we have. We have a slide and we have a pole. Well, we're talking about slope. Slope, rise over run. So the slope of our slide here, rise is 3 feet, so that's 3 over, run is 2, so 3 over 2. The slope of the pole, again, rise over run, rise is 5 feet for every 3 feet. So a lot of you could at least get to this part. What I noticed is that we maybe forgot how to compare fractions. So one way you can compare fractions is to turn them into decimals and compare your decimals. Because if we're talking about what's steeper, that means one of these fractions has to be larger. If it's steeper, it has a larger slope. So one way is to do your decimals, and if you change your fractions here to decimals, 3/2, well that's the same thing as about 1.5. It is 1.5, not about, equals 1.5. 5/3, this one is not perfect. This is actually a repeating decimal. So this is about 1.6. Well, I'm rounding, I have that to the 10th place. So this is actually 1.66 repeating. So I'm actually going to round that to the 10th place to be about 1.7. So if you change it to decimals, you can see that the pole is actually greater than the slide. And my explanation is because the slope is steeper. But another way you can compare your fractions is to get a common denominator and then compare your numerators. So a common denominator between 3/2 and 5/3 would be a denominator of 6. To get to 6, I multiply 2 by 3, 3 by 3. To get 3 to 6, multiply 3 by 2, 5 by 2. And this would give me 9 over 6 and 10 over 6, which still works out the same way. To compare fractions, once the denominators are the same, look at the numerators. 10 is bigger than 9, so again, the pole is steeper. I'll go over here. Pole is steeper. The slope is larger. And my math over there proved this statement that the slope is larger. Didn't have to do too much on this one. Don't overthink this. Question 8 says the equation of a line is y equals 2x minus 3. Write an equation of a line that is parallel to this line. Okay. Well, there could be so many different answers to this, but one common feature. If I have parallel lines, then the slopes are the same. So I'm going to first figure out in my original line, so I'm going to say original. I'm going to label this in my problem. Y equals 2x minus 3 is the original equation. The slope is in front of your x or attached to your x. That's 2. That's my slope. So when I write an equation parallel, that slope is the same. So I'm going to say parallel line. And I'm going to say y equals, well, the slopes have to be the same, so it would be 2x. Now, it doesn't matter what those y-intercepts are as long as it's not the same as the original. Because if it was the same, then you just rewrote an equation and those two lines are the exact same line. They're not parallel. They would be intersecting at every single point. So you can actually leave your equation like this, or you can just make up some other y value. As long as it's not -3, then you're fine. So you could say y equals 2x, or you could have the form of y equals 2x plus b, where b is any number except for -3. So some examples could be y equals 2x plus 1, y equals 2x minus 1. You could do any y value as long as it's not -3. So as long as it has a slope of 2, then you're perfect. So there are so many answers to this question. As long as you had the slope and a y-intercept that wasn't 3 or -3, then you got this right. Okay, I'm going to keep on trucking here. So 9, 10, and 11 all have the same directions. It says, find the slope and y-intercept of the graph of this linear equation. Okay, that's not too bad. Kind of glance in here. 9, y equals 2x minus 3. That looks like that's already in slope-intercept form. So that's y equals mx plus b. 10, y plus 5 equals -3/4 x. Well, that's pretty close to y equals mx plus b. Might have to do a little bit more work there. 11, y equals 7/9 x minus 3 1/3. That also looks like it's slope-intercept, so this should actually be pretty easy. No work really, except for 10. So question 9, I'm going to identify my slope. My slope, or m, is in front of my x, which is +3. My b, or my y-intercept, is after my x, which is -6. No work to be done there. 10, however, 10, it's not in slope-intercept form, but it's pretty close. I could definitely get it there. You cannot just say the y-intercept is +5. That's incorrect. You cannot say the y-intercept is the 5 because, first of all, y is not by itself. If you actually want to find the y-intercept, then you need to plug in 0 for x and solve for y, or just rewrite your equation. So if I rewrite my equation so it's slope-intercept form, that means I'm moving +5 to the other side. To move it, I'm subtracting 5. Saw people not do this. We have y equals -3/4 x does not change. It's still there, cannot be combined with -5. They are not like terms. And then -5 over here just hangs out. So based off of this equation now, I have it in slope-intercept, which tells me my slope is the number in front of x, which is -3/4, and my y-intercept is after my x, or which is a constant, which is just -5. Not +5. If you said that, you made a mistake and you got points off. Question 11. Again, also in slope-intercept form, so there's no work to be done. M equals B equals. M is the number in front of your x, or your slope. That's 7/9. My B is the number after my slope, which is -3 and 1/3. You could also rewrite this as an improper fraction. That would be doing 3 times 3, which is 9, plus 1 is 10. You can also have -10/3. Again, no work to be done, but being able to identify slope-intercept form in these problems here. Okay, guys, so question 12. It says, the position y in meters of a submarine after x minutes is y equals -8x minus 12. Interpret the y-intercept and slope. Well, interpret means explain. That means explain in words. If you just tell me what the y-intercept and slope is, but you don't explain to me what that means, I am not giving you full points. So, let's first just talk about what they are. You can tell me what these are. That's awesome. At least being able to identify it can get you some points. but the question's asking you to explain. So let's start with our y-intercepts, and that's what it's asking for first. In our equation, it's in slope-intercept, so I just need to identify which of these numbers is slope, or excuse me, my y-intercept. Y-intercept is always after my x, and it's the constant, which is negative 12. Well, in this real-world problem here, the y-intercept, and in general, y-intercepts represent a starting value. So when I'm saying my y-intercept is negative 12, what I mean, or the way I'm explaining or interpreting this, is that the sub is starting 12 meters below the water. That's where he's hanging out. Before no time has passed, they're just 12 meters below the water. So here, I'm going to say the y-intercept is negative 12, which really means the sub starts out at 12 meters. I'm choosing meters because it's in the problem. 12 meters below the water. This is no time has passed. The sub is right now just hanging out 12 meters below the water. Nothing has happened. No time has passed. That's just where we started. Y-intercepts are always starting values, and that was in your notes. Start is a key word to talk about slope, or excuse me, y-intercept. Slope, though, a lot of you got this part, but the slope is what really threw us off. So, first I'm going to figure out what is the slope. Slope is before my x. It's the number attached to my x in slope-intercept form. That's a negative 8. Just being able to identify that at least gets you some points. Now, interpret or explaining. Well, slope, some keywords for slope is that it's a rate of change. Other words talk about rise over run. We also have things talk about this is the speed. That kind of goes along with rate. Those are the same. So when I'm talking about my slope, well, let's talk about rise over run. Well, rise is talking about y values. Run is talking about your x values. So I'm going to actually rewrite my negative 8 so it's a fraction. So it's negative 8 over 1. This is saying my y in my problem, y says it's a position in meters. So this is saying this 8, it's descending. That's what negative is. Descends 8 meters. For, or per, the x value, or this 1, is talking about minutes. So this is saying it's descending 8 meters each second. Or each minute, I'm sorry. Each minute. So putting this in words, you could say it descends 8 meters for every minute. So I'll give you options here. Our slope means the sub descends 8 meters each minute. Or you could also say the speed. I like that one. I think that one sounds nice. The speed at which the sub spelled the word wrong, and I didn't even catch it until now. Spelled it wrong twice. Descends has an S. Okay, sorry. The speed at which the sub descends is 8 meters for every minute. Either of these are fine, as long as you can really associate that your slope is the meters that it's ascending over a certain amount of time. So yours could have had less words than mine, but this is really very, very in-depth as to what you need to write here. So I'm going to stop for this half. Please check the next video for the second half of your test.